State of Jupyter, I will try to make a broad overview. It's difficult to cover everything about the Jupyter project. Okay. Oops. Okay. Is it better like that? Okay. So first, I really want to thank Aurelie and Unfocus for allowing us to have events. Events like that are what allow us to spread the love of Jupyter. And everything. So thanks everyone. Just a tiny bit of background about me. So I've been a core developer of IPython and Jupyter since 2012. So basically, I was doing a PhD and I had a lot of free time, of course. So I decided to contribute a tiny bit in the Python community. And obviously, by the end of my PhD, I was doing a lot of open source and a tiny bit of PhD, but don't tell my boss. And that's how I got into Jupyter before it was Jupyter, actually. So 2012, and now I basically saw the birth of Jupyter was in the first conversation when we mentioned the first word Jupyter, with a Y, of course. And so there's a lot of things happening, and if you're trying to follow what's happening in the Jupyter ecosystem these days, you might feel like that. I can reassure you, it's my full-time job. I'm feeling like that. So I obviously can't cover everything. So what I will show here is only a really tiny subset of everything which is happening. But I hope it gives you kind of an overview of what can be done with Jupyter. So let's do a quick history of Jupyter. Everything started in 2001 when a graduate student who also was trying to slack on his PhD decided to write IPython. About a 150-line script to get a better Python REPL. And so that's Fernando. Fernando wrote that, well, almost 17 years ago. And it grew for a lot of time. And IPython is still going alive and well. And by the way, it's uppercase I, if you ever write IPython. It was released approximately at the same time as the first iPod. So it's a bit of a funny story. And that's a screenshot of the latest version of IPython. And you see that already we have a lot of new features. We have syntax highlighting. We have type completion that were not there in the first version. And so let's skip a lot and to 2012. So 11 years later, we released the notebook. So here you see a screenshot of a Jupyter notebook, but at the time it was still IPython notebook with mainly 6 really active members. So the community of Jupyter, let's call it Jupyter, even if it was not called Jupyter at the time, was relatively small. And so that was not that long ago. That was 6 years ago. And Jupyter was actually created in 2014 when we first decided to rebrand the Python agnostic part to Jupyter. And we have around 12 steering council members, around 20 core members that are active, but thousands of contributors. And that has grew really in the past 4 years, which is actually a really short amount of time. And so everything that I will show here is in the core. There is obviously everything around the ecosystem. I can't cover everything. But in the core, we have about 20 people. You can see most of them here because we try to meet all of us at least twice a year from all around the globe. We found that getting all together, it allows us to decide what we're going to do in the next 6 months and build community strength. It's much more efficient to have in-person conversation with high bandwidth. And you see that there is approximately, well, you can't see, but I can tell you, that there is approximately half of our members, about 10 people are academics, and about 10 are from private sector. And what you have to understand that for the majority of these people, working on Jupyter is not their full-time job. They're basically allowed by their employer to work, or they're volunteers, or they're teaching on the side and using Jupyter for their classroom. And there is about a third of the people on these pictures which real full-time job is to work on Jupyter. And when I show all of these people, it's not only developers. It's only people who manage events. It's people who try to write documentation, to reach to community, which is really important for the project. And so we wouldn't be able to be here today without well, the companies that allow their employees to work on Jupyter at least part of the time, and 3 foundations that are right now giving us money, giving money to Unfocus to basically move the open source project, and of course Aurelie, which is helping us with all the conferences, Jupyter Pop-Up today, Jupyter Pop-Up again in May probably, and JupyterCon in August, which will be the second time we do a JupyterCon, and it was really amazing last year, and we hope to bring something even better this year. So I tried to compile a few numbers during while I was doing this presentation. And so here is a Google Trend chart of the search for Jupyter. And you see that since about 2015, so shortly after we announced that Jupyter, that IPython became part Jupyter and stay IPython, since then the search for Jupyter and Jupyter Notebook has risen exponentially, so really fast. So that's on the left. And on the right, what you can see is the number of notebook files that you can find on GitHub. And as you can see, since in January, there was about 1.7 million notebooks, public notebook on GitHub. So obviously, because we are open source and you can download everything for free, we don't have really good statistics. And because most of the time in open source, you can't track users. Users don't like when you track them. They deactivate everything. They have caching layers and everything. They compile from source themselves. So it's hard to get really nice estimate. But I can tell you, for example, that we have on GitHub across 5 or 6 organizations, we have more than 150 repositories. Most of them are actually a sub-project, a package which is released. And if you make a back-of-the-envelope calculation that we release, let's be pessimistic and say that we release twice a year each project. That means that you get almost 1 release per day of one of the Jupyter sub-packages, which means that every day you can update and you will get something new. So it's really hard. You have all these balloons that you need to keep track of, and it's tough. And we have more than 1,000 contributors from various horizons. We don't know always where these contributors come from. We don't know if they're volunteers. We don't know if they're working at companies. Sometimes we can guess depending on their email, but it's really nice to see that this is really a vibrant community. We tried to do some calculation on back on the envelope by download number in Anaconda or on PyPI or on Debian, and we can estimate with conservative estimates that we have more than 8 million users worldwide. I had no clue if it was a lot or not, so I looked online, and there are worldwide around 21 million developers. And so not everyone which use Jupyter brands themselves as developers, but it gives you an idea of how many users we have. And North America is estimated to have around 4.4 million developers. If you use Visual Studio Code, last September they released some numbers, and they have around 2.6 million active users. And GitHub last September also said that they had around 24 million users. So we are moderate project, relatively big, with quite a few number of users. And to really reach out, what we try to do as best as we can is to make all our developer meeting live. So it can be boring technical discussion. You can go on youtube.com/c/IPython, which is our channel. We won't rename it because it's historical and there is all these videos. And most of our developer meetings are recorded and posted a few hours later. We try to make it live, but it's not always possible. And actually, we have people that are listening to that and sending us comments and asking questions. Maybe we could turn that into a podcast, but I don't know who would want to listen to technical discussion for hours. So that's basically like a few numbers and how you can follow what's going on Jupyter. And so Paco said that one of the main key points of this year was education with Jupyter. And I think it's really important to think about education, because the tools that the next generation will be using will define how they will do science, do data analysis, control or numerical environment later. And you can see Jupyter taking more and more space in the education domain. There are different ways of using Jupyter in education that really varies. You have completely hosted platforms like Grid or CoCalc, where you can subscribe, pay a fee, and they'll completely manage the classroom for you. And each of these has their own specification. That's more, for example, if you have a physical classroom. But if you're doing a MOOC, for example, some big MOOC platforms are using Jupyter, like edX. And of course, if you have training at higher level, O'Reilly is doing training sometimes in Safari online using Jupyter. And even if language that you don't expect, like for example, I was astonished to see that Go was start using using Jupyter. You have setups where instead of having more classroom with management of many students at once, you have Azure notebooks where each student have their own environments that are more flexible. And if you really don't want to opt into a hosted solution, well, we provide Kubernetes and Helm charts so that you can, on your own hardware, deploy Jupyter for education. And I'm not giving a specific example because everybody has different needs, but we see more and more people that want to have automatic grading, and we have nice projects in the core like NB Grader, and we have also many other extensions that allow you to adapt Jupyter, especially for education needs, like for example preventing cells to be edited by students, because obviously if you give the test to the students and the students say that change the test, then they suddenly pass the exam even where the mic is.
Yes.
Mic stopped. Ooh. It works again. And the student get a good grade even if they have the wrong answer. Let's talk about in-person teaching with Classroom in Jupyter. That's a class that is being taught at Berkeley right now. So that's the data science class that started this fall. And here you can see in the amphitheater there is 1,200 students taking data science at UC Berkeley using Jupyter. And the whole platform is managed by datahub.berkeley.edu that manages this class and others. And this platform can have I think right now up to 2,500 students. And that's 2,500 students when they will leave Berkeley to go into academics or private sector. What they will know, the platform they will know to do machine learning, to do AI, to do data science will be Jupyter. It's something that we think is great because you can basically use the same tool across all your career. You're starting as a graduate student, you learn Jupyter is the first thing you learn, and when you go later on, you don't have to be retrained. You can just use Jupyter again for your work. You don't have this couple of months when you have to adapt to your new tools. And you can see also Jupyter for education in MOOCs. Lorena Barba, her name has been named a couple of times. She's doing amazing MOOCs online using Python and Jupyter. And we see more and more books that are teaching data science using Python that provide all their examples as free notebooks online. So you can just download the notebooks, and if you want to run the examples, you don't have to get familiar with the command line and learn all this extra knowledge just to get the example to run. You just click on the button, you have your notebook, and you can go through the example and directly hit into the domain knowledge instead of having to learn all this extra information. And so we really see now that the Jupyter Notebook is and will be the platform used in data science because a new generation is coming and knows that. So if you're more interested in education, I strongly suggest you join the Jupyter Education Google group. It's a mailing list which is targeted for education. And you can find more information about that just on the Jupyter website. You have how to subscribe. One thing I've seen recently is that Jupyter is really loved in machine learning and AI. As soon as you see a blog post or you see a tutorial on machine learning or how to understand a neural network, they will usually use Jupyter. Because what has been said in the few talks before, you're basically trying to get insights into what's happening in the computer. And that's where Jupyter is great. You don't want to write your trading algorithm from zero to end knowing what you're going to do. You want to get insight into how it works and what are the key pieces. And that's where Jupyter is really nice for machine learning and AI. We still don't completely understand how a neural network works, and we want to be able to poke in it and see how they're seeing things. And that's why when you see, even in the official TensorFlow docs, you have notebooks in some area. When you see Kara's tutorial, you see Jupyter again. And again, because it's open source, often we see product appearing we didn't even knew were using Jupyter, and so we recently saw that Amazon SageMaker, that was released by Amazon, is built on top of Jupyter, and it's quite amazing to see that now you have a one-click machine learning platform available, which is based on a platform, on an open source project that 4 years ago did not exist and was built by a couple handful of people. And you see, even if Jupyter is used a lot in the Python community, you start to see adoption in other languages. So for example, you have the RBrain platform is building on top of Jupyter and on top of R, something specific to use R for neuroscience. And you see a lot of other projects. Google recently released Collaboratory, which completely run in browser, and in particular have this real-time collaboration component. And you see some specific projects around reproducibility in science with CodeOcean, Grid, which work with education, and even Google Data Lab has a lot of components built on top of Jupyter. I also want to say that we can start to see Jupyter in science, and especially HPC. It took some time to take off in HPC because there were some challenges to make Jupyter accepted in this domain. But we have a couple of really nice things. You might have seen the discovery of gravitational waves that confirm what Einstein predicted more than 100 years ago. What you may not know is that actually some of the analysis was done in a Jupyter notebook. And the people responsible for the discovery took the notebook and a subset of the sample of the data and put them online. And now you can just click on a link without even downloading it on your computer. It will spawn a server for you for a couple of hours in the cloud. And you can rerun the analysis and check how the parameters fit the data and basically listen to the sound of two black holes colliding. And it's really nice for reproducibility because you can check that everything they did and how it affects the result. So that's more Jupyter in a classical workflow where you use a notebook to analyze things on top of an existing platform. And there is an effort from the climate science community to gather all their tools into a single platform. And I invite you to look at PangeoData at GitHub. Where basically everything is using really new technology like Jupyter, Kubernetes, Helm, and everything, and basically provide a turnkey in the cloud platform where if you are in climate science and you want to participate, you can just install that, run it, and you have an infinitely scalable on Google Cloud platform that allow you to do data science. And there are some questions in some high-performance computing center. Will Jupyter replace traditional HPC and SSH workflow, especially as new people come in and are afraid of learning all these new tools and the command line, which looks scary, which is sometimes complex to install, especially when you have a wide variety of platforms. We know that especially for Windows users, it's not always easy because most Mac and Linux come with SSH clients. Once you have Jupyter installed on an HPC platform, you basically just need to tell people to hit a URL, and then they just log in by hooking into your normal credential, and then they have access to a supercomputer. So all of that are normal use of Jupyter, but you can also see that a lot of business has custom needs. We saw a few this morning, and I want to highlight two others that are, I think, really different directions that are building next to Jupyter and on top of Jupyter. One is Airbnb knowledge repo. Airbnb was struggling with the problem of people having knowledge of how things were running instead of having an institutional knowledge. And they came up with this platform that takes the notebook that are written by their data scientists and build reports out of that. It was relatively difficult to have these people do the analysis and write a report, because once you've done the analysis, you don't want to spend time just writing it for someone else. And with that, what they have is a nice, beautiful website where you just write a notebook, and it will convert it for you as something which is readable by your peers that will replace you in a couple of years, or even yourself in 6 months, because you don't remember what you did. And the other one that I really like is Stitch Fix. Did notebook. And basically what they did is they can make more assumption about their code. So basically their code is stateless. which means that in the normal Jupyter, because you have all the state on the disk or any request you make, we can't make assumption about dependencies between cells, while on Citrix they can, and what they did here is provide a plugin for the notebook frontend that is capable of analyzing dependencies between cells, and now you don't have these issues that beginners have into executing cells out of order. Here the frontend will do that for you. So when you rerun something, it will say, well, here the next cell has changed the state, so I'm going to have to rerun what was before. And what you can see here, when they re-execute the second cell, X doesn't print 17, but it prints 7 or 3, depending on the exact value, which is really nice. But again, here you have to make more assumptions that we can't make in core of Jupyter. And so this is to come to the fact that Jupyter is great and is really has really a widespread use because of all the tools integration. And in tool integration, there is kernels. The nice thing is when you use Jupyter, you can decide which language you use. Most of the time, you see it with Python, but we have a couple of really high-quality kernel. I heard that the Scala one is quite used. There is a Python one, of course, that we ship. The R kernel is getting more and more traction. The Julia kernel has quite a few traction, and I want to emphasize one, which is Zeus Cling. That relatively struck me. It's relatively rare to see people doing interactive C++, and the people behind Zeus basically made a C++ kernel. So you can have interactive C++ in a notebook. With tab completion, with everything, it completely implements the Jupyter protocol, even the MIME type rendering, which means that your C++ can be really efficient, really low level. You manage memory yourself if you want to. You don't need to if you want in C++. But you can just, for example, read an image and the image will be displayed, which means that with a C++ kernel, you can have at the same time the really powerful, efficient backends that can have really nice visualization dynamic. So you basically have something which really go from one side of the stack to the other. Of course, you need to know C++. I don't know C++, so I'm just going to gloss over exactly what is written in here. So tool integration also means that you have to integrate with front end. We don't force people to use Notebook. A lot of people do not like Notebook and already have their tools. And the nice thing is it's relatively easy to write a plugin for your specific interface and have it hook into Jupyter. And so you can see when we have the classic Notebook, I will talk about the Jupyter Lab again. We have some bindings for Vim Emacs, and we have seen recently plugin for Visual Studio Code or Atom or Interact. So basically, you can bring the power of the interactivity of Jupyter to any IDE that is not interactive at the beginning. And I want to also point out one thing that I discovered recently. Someone released on the App Store something called Juno, which is a native notebook interface for iPad. It does not execute code on the iPad itself, but basically it gets a menu when you say connect to a remote kernel and you give it some information. So for example, you can connect that to an HPC cluster, and you can basically control 1,000 nodes process from your couch using a touchscreen interface. Which is, I think, pretty crazy. When I joined the project a couple of years ago, I never imagined that something like that would happen. And last week or 2 weeks ago, we released Jupyter Lab ready for users. So I don't know if you've heard about Jupyter Lab, so I'm going to quickly go through what it is. It is a new version of the front end that has been rewritten from scratch to pay a lot of our technological debt we had on the classic notebook, because we were Python programmer and not JavaScript programmer. So a lot of things on the classic notebook were really like bad APIs that were not stable, that were changing every time. With Jupyter Lab, everything will change. Everything is an extension. Like even the core things that you get when you install Jupyter Lab are extensions. So if you write an extension, you're a first-class citizen. And Jupyter Lab can not only open notebooks, but a wide variety of other files. Here on this screenshot, you can see a notebook right here. but next to it you can see a CSV file. I think this one probably have something like 500 million rows. Above here you can see a JSON file, and you can see a GeoJSON file. So the GeoJSON file will basically display a map. So you can register your own handler for your own file. So we have, for example, a handler for genomic data, for any kind of file type can be rendered and can be in a nice multi-panel view. So basically, you have an IDE in the browser, but except that in IDE, I mean interactive. And so Jupyter Lab, you can install it side by side with Classic Notebook. They can run both at the same time. There is no change in file format and no change in protocol, which means that you don't have to be concerned about your files and everything you have not working in Jupyter Lab. The file and the protocol will work. You don't have anything to change. If you have extension, you might need to do some updates, but it's perfectly possible to have extensions that works both on the Classic Notebook and on Jupyter Lab. It has way better architecture. For those who care, it's in TypeScript, so it's strongly typed. So you have more ahead of time error messages when you do mistakes in extension. And the goal is to, at some point, deprecate the Classic Notebook. We have several steps. So right now, Jupyter Lab is opt-in. You have to install it separately. When it will be more stable, we will install both. When you install Jupyter, we will install both the Classic Notebook and Jupyter Lab. And in a couple of years, we'll have to install the Classic Notebook manually, who will not disappear, who will still be here and maintain depending on the request and investment from the community. So it's ready for users, which means that you can expose Jupyter Lab to your users now, and we're ready to have feedback. It won't crash back in their hand. It won't crash more than the Classic Notebook. If it crashes, it's because the browser is crashing and get too much data, and we can't do anything about that. If you have extension, it's time to start to port them. It's not too hard. We have way better docs, and the nice thing about you porting your extension to Jupyter Lab is that the API will start to get stable and documented. And Jupyter Lab will have all the new features that the Classic Notebook will not have, because we will we'll try to retire it in a couple of years. And I will stop here for Jupyter Lab, but if you have more questions, come and see me later. One other key point in Jupyter and for multi-user adoption is Jupyter Hub. So Jupyter Hub, despite its name, does not work only with Jupyter. It's a key for multi-tenant system, but it's not limited to Notebook. We actually have people that use Jupyter Lab to spawn RStudio or OpenRefine, or even if their user choose, do you want to open Jupyter Lab or Jupyter Notebook or RStudio or OpenRefine, and Jupyter Hub will handle that for you. It's basically a proxy which is independent of basically that turn a single user application into a multi-user application. So try to forget the Jupyter part in the name. It's also a key piece for reproducible research. The Binder project was born a couple of years ago, and the Jupyter team adopted the Binder project a couple of months ago, and we rewrote everything to use Jupyter Hub. So basically, Binder helped us to design some decisions in Jupyter Hub. And basically, what Binder does is create on the fly for you a Docker container from a GitHub repository. So if you have a GitHub repository that has notebooks and data files, you can, in one click, create a Docker image in the cloud and run it, and then check that everything is fine and change the dataset and change your algorithm and see how it interacts. Binder itself is a version which is stateless and will basically throw away everything after 2 hours. But if you want to, you can configure the Jupyter Hub, which is underneath, to persist that. So if you have a paper and you want to reproduce the data on something else or use a new algorithm, you can spawn your own Binder version that will basically persist that and recreate a Binder for it. So we are pretty excited from the scientific point of view to have reproducibility and trustworthiness, so that Citizen Lambda that doesn't have the ability to buy and spawn up a cluster on Google Cloud can just click and check that the research is correct and trustworthy. And Jupyter Hub also help a lot with integration into existing environments because it hooks into a lot of authentication mechanism, and sharing and so on and so forth are going to come. So let's try to talk about things to come. There are a lot. I'm only going to talk about a few. So real-time collaboration. I think a lot of you and a lot of people have been excited about real-time collaboration and asking us about that for years. Every time we have to ask people who told us, when do we have real-time collaboration? What you mean about real-time collaboration? Because there are really different meanings, especially as soon as you start to execute code. When you have several people editing a document, it's just editing a document, it's fine. As soon as you have to run code, who do you impersonate when you run code? And this is always a problem that is hard to tackle, both on a technical point of view and on the user interface point of view, because you have to communicate that to the user. That's something that Collaboratory that I mentioned earlier solves, but by executing everything in the JavaScript engine of the browser, so you basically have something which does not persist. But personally, when I'm doing data science, I want to load large data set from disk and run it on a cluster, and I can't do that on the VM of my browser. So that's one of the solutions where basically you say, well, no, there is no kernel state, everybody like run in their engine. And so if you really have questions about real-time collaboration, I will invite you to talk with me later. So let's talk about just real-time collaboration at the document level. Can several people edit at the same time? So first thing we said is that we want to hook into Google Drive. The good news is that it works. It works since last December. The bad news is that Google Drive real-time API has been deprecated since last December. So basically, it works, but we can't release it because we can't create a new application that does real-time collaboration. So if you have an application that does real-time collaboration, the code is on GitHub. You can npm install it on your Jupyter lab. The UI is not perfect because we say, well, it's deprecated. We're not going to push that too much forward. But you basically can invite something with their email, and you can type. Both person can type in the notebook. You'll see their cursor. You have live edition. Everything is synchronized. It's saved on Google Drive. There is still this question of who executes, which might be tricky when you run it. But it works. And it means that the infrastructure of Jupyter is able to handle real-time collaboration. So now the only things we need to do, only with which code, is actually write a backend that does real-time collaboration on the server side. And so basically re-implement the server side of Google Drive real-time collaboration API, which is in progress, but it's quite hard to do. And we don't have that many developers. In the meantime, as I said, if you want real-time collaboration, you can fall back on services which already implement them. So Google Collaboratory does that on using Google Drive API. Because they're Google, they can do what they want with Google API. And CoCalc, who also implement real-time collaboration in Notebook, as well as time travel, where basically you can roll back to any previous state. But again, they can do that now because they make more assumption about what their client wants. And it will take more time to be in core Jupyter because we want all the API to be compatible with any use case, whether you want to deploy that on Google Cloud or whether you want to implement that, host that on your own premises, because a lot of people want real-time collaboration in a case where they don't want to share data with Google, which I understand. Let's talk about Road to Jupyter Hub 1.0. 1.0 will probably not be the actual version number, but more saying what we are looking for. So we have a nice talk this morning from Scott about how to scale to 100K and plus users. We want to bake most of what has been learned by community members into the core of Jupyter Hub, so that it doesn't take you 3 months or even 3 years to have to spawn your own Jupyter Hub for hundreds and thousands of users. It will take some time to get all the pieces in place. And so you have questions of scaling horizontally and vertically, like getting more user per hub and also getting more hubs next to each other and not sharing state. We're so far starting to hit roadblocks in Kubernetes and Helm and everything, so we need to to look for solutions for that. Jupyter Hub will also have a lot of work on sharing, integration, and real-time collaboration. I put real-time separately from collaboration because it's a really hard problem. We want to have all the hooks necessary so that you can share files, collaborate in a more asynchronous manner like Git. And both in a view-only mode or edit mode, run mode, you can run as me, etc., and so on and so forth. And again, we will take time to lay out all this API, and we welcome your feedback on that to inform us on what is needed. One thing we will work on is Binder and federation. So right now, Binder is a product that allows you to run a repository for free on the cloud. We can't run everybody's code on the planet for free, especially if you have 8 million users. So we're trying to figure out how you can, as an institution, say, hey, I want to be part of this federation, and when my employees are coming and clicking on the buy down link to have a repository, I want it to be able to be spawned on my infrastructure, so that then I can provide with specific hardware, like for example a GPU or a TPU if you're doing machine learning. And it's challenging to be able to describe the hardware you need in a vendor-independent manner. And there is also a lot of security concern because you're now not only running someone's code that you don't trust, you're also letting us allocate hardware on your machines, which is a bit frightening. There is also there will be also a lot of work around auditability of Jupyter. Like we have more and more large-scale deployments that need to basically have really carefully audited logs because they're working with sensitive data, with private data, with medical data. And there is all these questions like how do you prevent someone from copy-pasting data out of a notebook? When the notebook is out of focus, do you want to blank the screen because someone may be passing by and see something which is sensitive? There is also all this compliance with HIPAA and GDPR, which is happening in Europe. And even if GDPR is in Europe, it is going to affect users all across the globe. And so we have a number of people who are starting to get together. We might get a meeting at JupyterCon this August to discuss that in the business summit. How can we make Jupyter compliant with what you need? And so that will be one of the large focus of the next year or so on Jupyter Hub and all the underlying Jupyter components that need to be aware of that. If you want to know more, this event is only one day, so I would suggest you come to JupyterCon in August, August 21 to 25th. On 25th, we have the Sprint Day, which is open, which is just next to the conference. You don't need to have a pass to the main conference to come to the Sprint Day. We have, I think, less seats than for the conference, and there will be a lot of things happening during the Sprint Community Day. We also write documentation. If you're new to Jupyter and want to get started and you have never contributed anything, you're welcome to come. If you have never used Jupyter and want to come to discover it, you're welcome. If you already have a project which is not in core Jupyter and you want to pitch it to us and get people to work on that, you're also welcome to come to the Sprint Day. There will also be tutorial in Jupyter that will be announced soon. As a call for proposal ended 2 weeks ago, and we're going to announce as soon as possible what is going to be the program of the conference. And now, well, for the rest of what's going to happen to Jupyter, it's up to you. If you are using Jupyter, we want you to give us feedback, what you need. If you can do it publicly, come on the public channels. If you can't or are afraid or everything, you can contact us privately and send us something. We will keep it private, but we will use that to inform our decision. And if you start to contribute to Jupyter, there is a high chance that in a couple of months you will get commit right, and in a year or so you will be part of the steering council, so you can decide for the direction of Jupyter. And so you can, of course, participate to the community, and you can also, what a lot of people have done here today, come and showcase what you're doing with Jupyter. And with that, I'm going to thank you and take a couple of questions if you have time. Otherwise, we'll probably move things earlier to let you go home in the blizzard.